Okay, so in this course, we're going to know about what is data flow, how data flow works, and what is the importance of data flow in Google Cloud Platform. Also, how to make different pipelines and how Apache Beam is being used for making different pipelines. But what is data flow, right? Data flow is a fully managed, scalable data processing service for executing batch, stream, and ETL processing patterns. What is batched and what is stream? Like the terms used, I have used, or you can see on your screen. So batch data is a type of data which is fixed, and stream data is a type of data which updates at every interval of time. You just need to understand these two definitions at this moment of time, right? Now, data flow can be used to create data pipelines that read from one or more sources, transforms the data, and write the data to a destination, right? What is pipeline? So, pipeline is nothing but a flow chart or a procedure data follows for its processing, right? We will understand in depth about how we create pipelines, how we use pipelines, how we deploy pipelines. Even we'll know how we deploy pipelines with collaborating with a template in the further video, right? Now, for making pipelines for the data flow, we actually need a SDK. And for this work, we use Apache Beam. Now, what is Apache Beam? In simple terms, we can define it as a tool for creating pipelines for the data flow. It is a unified programming model for batch and streaming data processing jobs. Now, it has some key points or key attributes, that is P collection, P transform, pipeline, and pipeline runner. Pipeline represents a directed acyclic graph of P collection and P transform, and it actually encapsulates P collection and P transforms and then applies data processing job on it. Pipeline runner is nothing but it is used for executing the pipeline we have created, or either we are using a pre-built pipeline, right? Now comes what is P collection and P transform. P collection actually represents a data set which can be a fixed batch or a stream of data. P transform is a data processing operation that takes one or more P collections. That is, it takes one or more data set and outputs zero or more P collections. It is as simple as that, right? Now, what is batch data and what is streaming data? So, batch data is a type of data that is fixed in size and is not updated regularly. Or we can say it is not updated at a regular interval of time. Batch data can be stored in CSV file or any other file format, right? So now the other term comes here is what is streaming data. Streaming data is a type of data which updates at every interval of time. Like that interval can be anything, like either after every 1 second, either after every 1 minute or 1 hour or 1 week, etc. This type of data is used in many types of real-time applications like stock market, which actually changes and updates data at every 1 second. Okay, so how Apache Beam actually works or how it actually goes from one end to the other, right? So in this flow chart or the diagram, you can see that first comes the data source. Here the data source is the pub sub sending the data, which is actually getting the data from the user. That data is then going to the IO connector, which takes that input and then sends it to the P transform. This data, which is actually traversing, is the data we can say as P collection. This P collection is actually traversing to the P transform, where the P transform is responsible for transforming the data. Now, this transforming the data means it can transform the data in many ways, like splitting or extracting important features. Here we can see in the flowchart the P transform is actually transforming the data into two other P transforms, where it's the P collection data is actually going to the IO connector, and this IO connector is responsible for giving the output destination. It is as simple as that, right? So this was the flow how Apache Beam actually works. We will review and we will discuss the in depth how it actually flows and how the data is processed in the further videos. Okay, so now we when we create a pipeline, right? We have two options. The developer or the user have two options. Either to deploy that pipeline directly or use a data flow template. Now, what is data flow template? Data flow templates allow you to package a data flow pipeline for deployment. Actually, what it is doing is like it is encapsulating the data flow pipeline which the user or the developer has created, and that encapsulated template can be used by different developers at different or particular time, right? Anyone with the correct permissions can then use the templates to deploy the package pipeline. These are some benefits of using templates rather than deploying a pipeline directly. Now, there are two types of templates, classic and the flex. Flex is the most used one, and it is the most recent template which is used by the developers. With a flex template, the pipeline is packaged as a Docker image in artifact registry along with a template specification file in cloud storage. Now, this definition comprised of two main terms, Docker image and artifact registry, right? What is Docker image? A Docker image is nothing but it actually contains application code, libraries, tools, dependencies, and other needed files, and which is actually needed to make an application run. It's just like, or it's actually encapsulates all the important files together. An artifact registry is a service that stores and manages software development packages, right? So this Docker image actually gets stored in this artifact registry if we talk about with respect to Flex template. Now comes the classic template. Okay, so classic template is a type of template which was used by the developers in the previous time, and now the most used template is the Flex template, and the most recent one is the Flex template. But what is classic template? Actually, it contains the JSON serialization of a data flow job graph, right? The code for the pipeline must wrap any runtime parameters in the value provider interface. Now, the term here comes is as what is value provider interface. So, value provider interface is actually divided into three parts, right? The first one is the runtime value provider. Second one is the static value provider, and third one is the nested value provider. Runtime value provider is the default value provider, or we can actually say it as a value provider. We can actually term it as a value provider. It allows the pipeline to accept a value that is only available during pipeline execution. The value which is not available during pipeline construction. So you can't use the value to change a pipeline's workflow graph, right? So what this value provider do is like it only allows the pipeline to accept a value that is only available during pipeline execution after the execution of the pipeline or during the execution of the pipeline. It doesn't allow any value to be accepted. Now comes the static value provider. Static value provider lets you provide a static value to your pipeline. The value is available during pipeline construction, so you can use a value to change a pipeline's workflow graph, right? The third one is nested value provider. This type of provider actually computes a value from another value provider object. Nested value provider wraps a value provider. Like the name only is like indicating and suggesting that it actually takes the value from another value provider object. But this type of value provider is actually used, like not used by the developers or users frequently. The most used ones are runtime value provider and the static value provider. We will get into depth about these three types of value providers with the code in the further video.